Hello everyone, welcome back to LeetCode Daily Life, where I do the daily question, raw and uncut. So we have an easy today called maximum difference between increasing elements. So given a serial index integer array nums of size n, which is only up to 1,000, okay. Find the maximum difference between nums I and nums j, such that, well, I is smaller than j, and also nums I is smaller than nums j. Right. So, okay. So for this thing, it has to be positive because nums I has to be smaller than nums j. Return the maximum difference. So we want j to be as large as possible. We want I to be as small as possible. But then I has to come before j. Okay. So we want the maximum difference, and if none of them exist, return -1. Okay. Let's look at some examples. So for nums here, we have 7154, which returns 4. I guess, yeah, that makes sense. So you might ask, why can't you use like 7 and 1? Well, that's because the larger number has to come after the smaller number, and in this case, like 7 is before 1, so we can't use that. Okay, and then example 2, 9432. Well, all the numbers get smaller, so like there couldn't be a pair where the later number is larger than the earlier number. And then example 3, I guess this one is also like pretty obvious because like you have 1 and 10, like they are the most like far apart, and 10 comes before 1, so we would just return 9 here. Okay, well, I think for this question, all we have to do is we have to keep track of the current smallest number that we are seeing, and like we basically just well, I just check for each number minus the smallest number, like whether that's greater than the current like best difference or not, and then yeah, and that should work. And also because the bounds are so small, you can technically also just like do an n squared like an n squared solution and just loop through all the possible pairs as well. But I'll code up the smarter way this time, I guess. So yeah, so what we want to do is we want to have a max difference. So we'll set that as -1 at the beginning, and then we can just do a current minimum. So we can just set that as 7. Oh, not 7. Oops. We should set it as num0. So the first element, because like the first element could never form a pair as the bigger number, right? So we can always just do that, and then like here we'll just not loop through the first number. So in range 1 all the way to length of nums. So we want to get the current number. So I guess we can just do like max difference is equal to the max of max difference, so the running maximum compared to our current number minus our current minimum. And then for the next number, we can update our current minimum with nums I, if nums I is like even smaller than our current minimum. So I think we can just do that, and then at the end return max diff. And if we have a case like 9432, it should not change the max diff, so therefore it will just return -1 at the end. Oh, oops. I did something wrong. Oh, okay, because does it have to be? Oh, okay, yeah, okay. That's kind of my bad. So if the maximum is, so if the max diff is 0, we want to return -1 as well. Okay, so I forgot about that. So we can do return max diff if max diff is not equal to 0, else -1. I think that should work. I hope. Alright, nice. So yeah, Yeah, before I explain the solution, yeah, I've been really caught up with stuff to do, so I couldn't post last week, so I'm sorry about that. I'll try to post more this week. And yeah, so let me explain my thought process now, I guess. Well, so I guess like I don't really have to explain the pairs thing. Like if you just check every pair, like it will be an n squared solution, right? But I'll talk a bit about the ON solution. So what I'm actually doing is like if I have 7154, right, let's say. Um so like if we are looking at maybe I can make like um maybe a 2 here, right? Let's say something like is that a good idea? Uh, if I change this to 8. So let's say we have like this array here. Um, well, how do we quickly know if we use 8, what number can we pair with so that we can form the maximum difference? Well, obviously, we'll look at the smallest number, right? Because if we look at the, like, not the smallest number, well, you have like the current number minus like some number we choose, right? And we want to maximize this thing here. We want to maximize. That was a terrible handwriting. But if we want to maximize this, we want to minimize this, right? So of course we want to choose the smallest here. And what about for the next number? Well, we'll want to find the smallest like for this range, right? And if we have like even more number, well, we just want to find the smallest within this range. So if you just have a, like if I have the current minimum, well, like this variable here that keeps track of like the current smallest elements, well, we can eliminate checking for like every pairs, right? Because like the only possible pair that could be the maximum difference is if we are dealing like it is the pair um that subtracts from the, well, that subtracts the smallest element. So that's kind of how I thought of the solution. But yeah, this question is pretty straightforward. It's an easy question. So I hope my explanation kind of helped. And yeah, thanks for watching. If you have any comments or any feedback, let me know below. So yeah, thanks for watching, and I'll see you tomorrow. Bye.